So we're building towards here a way to study circles on the coordinate plane. But to start, we're just going to look at some new ways to use familiar formulas. So really, we're just using Pythagorean theorem on the coordinate plane here, and maybe we're going to find a way to simplify it a little bit. Now, because Chicago is a nice grid system, like the coordinate plane, I thought it'd be interesting to tackle a real-life distance problem using our formulas here. So what we're going to do is we're going to go from Augusta and Kedzie to North and Costner. So I chose this area because I've lived in this area the entire time I've lived in Chicago. I know that some of you probably live over here as well. Augusta and Kedzie is down here, for those of you who are not as familiar. North and Costner is over here. So Augusta and Kedzie down here, that's like where the pool is at Humboldt Park, and then North and Costner, I don't know what's over there. Like the Walmart is up over there. North Grand is right over there as well, North Grand High School. So that's where we're trying to go. And the question is it better? Is it better to go up Kedzie and then over on North? Or is it better to take that diagonal Grand Avenue? And we're going to assume that both streets are equally fast, although I think like driving Grand would be faster. But we want to pick the smallest distance. And then what you need to know to tackle this problem in this way is that every street in Chicago has a number, and it's like coordinates, right? So Kedzie is 3,200 west, Costner is 4,400 west, and then Augusta is 1,000 north. North Avenue is 1,600 north. So you can actually use these numbers to kind of navigate around the city just by looking at the house numbers on buildings. You'll have a rough idea of where you are if you're familiar with this. So I'm going to treat these like coordinates. I'm going to drop the zeros, but I'm going to label my spots here. So this is Augusta and Kedzie, so I'm going to put 32, comma 10, like X and Y. And then here I'm going to put 44, comma 16. Okay. So what that means, right, is I can figure out the lengths of each side, and then I can use those to figure out the length of the diagonal as well. Grand does not have a consistent number because it runs diagonally over here. So let's see. Here, this side would be 16 minus 10, right, which would be 6 units. And this side would be 44 minus 32, which would be 12 units. 12 blocks, really. Okay, so I have 12 blocks for one side, 6 blocks for the other side. So we just figured out Humboldt Park is 6 blocks long, which is about right? And we want to know how many blocks is this diagonal. Well, we already know the math to do that, right? We could be like 12 squared plus 6 squared equals, I'm going to call that D squared. But it's really C, right? And then I get 144 plus 36, so 180 is D squared. So D is the square root of 180. Which you could tackle this a number of ways. Here, I'm just going to use a decimal because that's going to make it easy to compare. So that's 13.41 blocks. So that's what we just found. We found this D side is 13.41. Okay, well, it looks like that's quicker, right? Because 13.41 is less than 12 plus 6. So obviously we should take Grand. That's actually true of any right triangle. The hypotenuse is always shorter than the sum of the other two sides. So that's why it's better to take Milwaukee to the blue line, right? Instead of taking Ashland or something like that from Noble. Okay. So notice what we did here is we subtracted both of our points, right? To get the sides of our triangle, we looked at the difference between the two. That's going to become important later. And then if we want our halfway point, well, a halfway point, a way to think about that, so we're taking the shortest way. We want to know when we're halfway there, right? Our halfway point is going to be the average of the coordinates, right? So what I can do is I can be like, okay, my halfway point is going to be 44 plus 32 over 2, comma 10 plus 16 over 2. And so what I did is I just added my x coordinates, added my y coordinates together, and divided them both by 2. And what we get here is we get 38 when we do that math for my x coordinate, and then 13. So that spot would be right here, right? Right smack in the middle, and Hamlin is indeed 3800 west. So we did our math, right? 1300 is whatever's right above Division. I don't know what the exact street is, but we're going to be like a little bit north of Division. Okay. So what we've done here is we've used 2 formulas that we're going to use eventually to examine circles, but for now we're just going to use to look at the relationship between points.
The first of the 2 is the distance formula. And to find distance, what we did, right, is we looked at the difference between our x-coordinates. We squared it like Pythagorean theorem. We added to the difference between our y's. And remember, this would be equal to the distance squared. So the way we're going to write our distance formula is we're going to take the square root of the whole thing. So that's my distance formula. And then my second formula is my midpoint formula. So you can use m or say mid. And the midpoint formula is just the average of the 2 points, right? So we're going to write it as an x comma y. And it would be x2 plus x1 comma y2 plus y1. Now, a common error that I see, I'm going to warn you about now, is make sure you pay attention to the signs here. So distance is a difference, right? Minus, minus. Midpoint is a plus and a plus. So don't get those 2 mixed up. You'll have a chance to practice these here on your homework. And then we'll just do a quick algebraic example. So A is negative 4 comma 5. You guys know how to plot these points. And then B is 3 comma negative 6. So here's my segment. And we're looking for well, we can do better than that. Okay, so we're looking for the distance and the midpoint. Distance would look like this. Right, so we have x, y, y. An interesting thing about this is the order doesn't actually matter. So I could switch these around and I would get the same result. So it would be 3 minus negative 4 here squared plus negative 6 minus 5 squared. And then I get 7 squared plus 11 squared. Negative 11 squared on the inside. And then that ends up being 49 plus 121 on the inside. And we'll just leave it as a square root in this case, square root of 170. That's about 13, I think. But you can just leave my square root alone. That one does not simplify, and you can double check if you don't believe me. And then my midpoint, we'll use a different color for this. My midpoint is going to be just the average of the 2 points. So it'd be negative 4 plus 3 over 2, comma, negative 6 plus 5 over 2. And then I get negative 1/2, negative 1/2. My answer here is a point. Negative 1/2, negative 1/2. So that's about right here, right, is my midpoint. And that looks to be the middle, so we know our formula works. So here's your examples. You guys, I think, are going to have a really easy time with this one as you get to practicing.